Welcome from our side. Happy to have you here. The topic of today's lunch and learn, or in our case, since we are just Europeans here, is probably more dinner and learn. What we would like to talk about is talk to your data, which is, as you probably all know, quite quote unquote famous concept in the whole data analytics AI industry in the moment. So putting chat interfaces specifically on your existing BI infrastructure instead of canned, quote unquote, canned reports or dashboards. What we would like to talk about today is a very specific application of that. What we did last year was actually a project which we did together with ESA, so the European Space Agency, and we put or built a demo or prototype to talk to Earth observation data. And I don't know whether you are aware or not, but ESA has a program running which is called Copernicus, and they are basically photographing from satellites the Earth constantly and in different frequencies also. And that allows for several types or a lot of different use cases or to answer several questions, also from a consumer perspective as from a B2B perspective. But from a consumer perspective is actually what we focused on with this prototype more. And there are questions like, what is the air pollution? What is about the snow caps? How did they develop in the Alps or other areas in the world? And that's actually an example you're going to see in a few moments when Benjamin shows the demo. Or what is about the forest development, fire warnings, or maybe also water pollution or quality of the water if you want to go swimming somewhere in a lake nearby. The issue with that is that you cannot make sense out of that Earth observation data without being an Earth observation specialist. And in order to bridge these gap, we built this prototype, which is used for ESA to demonstrate how and consumer quote unquote ready consumer ready prototype or a demo or application or access to Earth observation data could look like. What is important here to mention is it is, as I said already, it is a demo. It's a prototype. It's working actually in a quite breadth of different use cases, but it's not a full-fledged application. So keep that in mind when Benjamin is showing that to you. So what we want to do now in the next remaining 40 minutes is first that we do a little bit of introduction round. We will do that immediately after I stop talking. And then Benjamin will take over and guide you through a small demo so that you got a feeling what Talk to Earth is actually about. And then he will also share some insights about what is the architecture, because there are different AI agents involved in that, and also share some insights, some findings we figured out on the way developing it. So then let's go. Let's start with the introduction. Benjamin, could you move, or I go to the
Yes.
board? Hang on, I go to the board and I bring everybody to me. Uh, and I did already a little example here, which is myself. So I'm Georg. I'm one of the managing directors of Datentreiber. Today, I'm your host and moderator. That's probably more important. And what do I expect, or what do I would like to have from this session today is actually I want to inspire you, or we want to inspire you with some ideas and also, of course, some insights about this approach of chat interfaces to data, and in this case, specifically to Earth observation data. So let's take, Benjamin started already. Let's take 2 minutes. So Jan, Martina, we have another participant, Yale. Okay, okay. So we need to post the
Yes.
board link again, probably.
Yeah, I did it one more time, but I think Phil
Okay,
joined.
I do it also. again. So all of those who just came into the call, we just um, put the board link in the chat. If you click on the board link, you should be able to get to the Miro board, and then we could do our little introduction round. Let's put the timer on. Anyone who hasn't got the board link? So it's 6 people on the board. We're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the call. So if you like, you can also switch your video on. That is actually a little bit more pleasant from our side because then we don't talk to just the black picture. Mhm. So Martina is using, or how many minutes do we have left? So we have 1.5 minutes left. So wait a little bit and give the other ones also a chance. Okay. Mhm. So let's look through that. So Benjamin, yeah, okay, that's fine. So Martina is looking for some inspiration. Yep, I hope we can deliver that. Philip is about gaining some insights about agentic AI. Yeah. Jan would like to see some inspiration and get an impression. Okay, fair enough. And Ramon just started my freelancing in data in a AI advisory. First time participating in a data and AI community, getting first impression. Yeah. Okay. All right. Good. Then I would say, Benjamin, um, we go to the agenda. Let's do a
Yes.
demo of Talk to Earth.
Right. So I will take it from here. Can you hear me and see the screen? Well, if not,
Yeah.
then share it, please. Yeah, we thought that we first make a little walkthrough and just show because we built Talk to Earth, which is an about Earth observation data, but still it is talk to your data. And maybe at the end we will understand a little bit more how we can also maybe transfer what we learned to other talk to your data systems. So can you see the interface, Georg, as well?
I
Like,
can see it. Yeah.
right, okay. So this is a prototype. This is also important to know because it's not the most fancy design. So we had a short time to design it, and what we wanted to prove is the ability of Earth observation data from ESA by dialogue, by a chat interface. So this is why we came up with this user interface. And I would just make a little walkthrough and show you one run or how a user would approach it. We have here this colored buttons are prepared pathways where we knew that the use case or the prompt that we asking will deliver a certain result that is okay. We know this works, this use case, because Talk to Earth is a dynamic system. So you could type in anything here. And if you have, like, if you're a user and especially a non-Earth observation expert, you can just think of something that would be useful to you and ask the agent if this is possible to convert into an Earthlet, because this is how we call the mini apps that will then run. I will just show it here. This is like the most basic thing. This already shows, so you can see here's a map. I'm located here close to Berlin at Eberswalde. And this is an Alpha Earth embedding. So you can see there are different maps layered. For example, I can show you here. So basically, this is what Google Earth is delivering in terms of data. It's like pixels, and you can query different pixels and different colors, and then apply analytics onto it. This is basically what Earth observation is about in a very, very reduced form. And for example, here you can see this is close to Berlin. This is Berlin, the green thing. And for example, this red pixels show the change that has happened in a certain area. And here you can see the Tesla factory that was built. For example, here you can see it was not there. And then at 2024, it was built. 2018, it was not there yet. And the difference is then calculated, and it's colored red. And so you can see visually, okay, a change has happened. But this is a very simple use case, most straightforward. But I wanted to show you also how the dialogue could work. And I will just choose one of these demonstration pathways, because when I now click this, we first have a quick start. So here it says, show me the Hornsea offshore wind park, build radar for center. And then I put in the latitude and longitude. So this assumes I, as a user, knows it. Doesn't has to be the case. I could also just talk to the agent, and then we figure out together where it exactly is, because the agent has access to geolocation API. And yeah, for example, then now we see the first time where the agent is really queried, like a prompt is sent to the agent, and so it needs to calculate, to get on the task. So it has a duration. It needs some time. And now we can see that it's already generating code. And this is also something important to know. Like we will see when I show you the architecture. We develop, or the agent is writing complete Python code in the background. And this Python code is then responsible for querying the Google Earth Engine API, and of course, showing us the output to the user. This is in this case we used a third-party library called Folium, which delivers this map view. So as you can see, it takes a while, but I think a little bit later we will understand why it takes a little bit longer than just a simple SQL query. Because I will show you the code. Uh, that's a long time this time. An
Yeah.
error. That's interesting.
Okay.
This is a showcase. Okay. This hasn't happened like for a long time. I'm
Mhm.
sorry. This is the Vorführ effect, we say in German. Okay, let's try this one. Um, as like we also have a repair agent. So normally when this happens, when code is outputted that is not runnable as a mini app, then we have an agent that has access to web search and can then repair the code. But of course, this will take a little bit longer, even longer. Um, but usually it should work now. Any questions so far? Should I talk slower or?
No, that's fine.
All right, and I will already go here because then I will lead you through the architecture. So now it worked. So this is really dynamically built by the agent, the coding agent, because we have two agents, a dialogue agent, a user agent, and an agent that writes the code. And we'll see shortly why that is the separation. But as you can see, now I have like a night light view. So this means I can see when there was a blackout. For example, here there is light in the city at nighttime, and here there was a blackout. And also I here have a time series that shows the drop. And there's a general drop, and because this is Ukraine, like this is the Ukraine war. And here we have essentially the description of the agent to the user that is not an Earth observation expert about what they are seeing. And this, for example, is also generated at runtime and is driven by the prompt, by the system prompt. So the system prompt kind of knows, okay, I have code, and this is also a good time to show you the code. So this is the code that was just generated, and this is what we are seeing here. So this is, I mean, yeah, it's not a full program, but it's also not so short. So we have a mini app. This is essentially what it is. And of course we can share. I will just show.
Wow, it's really slow today, huh?
Yes,
Upsala.
but maybe I have a suspicion because we run on Google Cloud and we slowed down the performance to save costs because we're not like this is an app we developed in November to show at ESA. And maybe because now we're many people or some more people accessing it, could be the lazy explanation. But yeah, so we see here, those are all like earthlets. And some of them, this is like a catalog. Um, all those earthlets represent code, Python code, and they all are representing different use cases. And some of them have been prepared like templates from our Earth observation expert Philip back then. And some of them are user generated. Like, for example, I saw something with Santa Claus here, Santa Claus. So this a user generated this. I don't know, but it is supposed to show you where you're most likely to encounter Santa Claus. I just found it when I when I checked it this evening. So then of course you can share it. So when you share it, you get a link, and as you can see here, this is very basic. Like we have um, the earthlet name, and this will lead you to the earthlet. You can send it to another person, and then they will see exactly this earthlet, and then they can reiterate on it. Like I could now start to ask something or change it, and then it will become a dynamic process again. Yeah, I think that's like a rough overview. And let's change to, because we don't have so much time left, to the architecture. So I put this into three phases, like the UI, the agents, and the data. And I think the UI, we can make it very quick because you saw already what is happening. Like a non-Earth observation expert can enter via talktoearth.com and will find this browser or the mobile or desktop application. And this is the Streamlit application. This is we built it on Streamlit because we figured that this is the fastest way to make a prototype, and it it is a prototype still, so it's not a production ready thing. And then of course the user puts his prompt, and he can also click buttons as we saw. So you have the agent response. We also have suggestion buttons. So the agent suggests something that you can just click, just like the demo buttons. And of course, you can talk. You can just put your query, your prompt, and whatever you want to say or ask.
So I can actually say, show me the air pollution of the nearest lake. Show me the water quality of the nearest lake I would like to go swimming in.
Yes. Maybe let's do this one time, because then you can see also. So and then we will also see how the agent right now reacts to such a query, because it's very vague. Like it could be anything. And what the user agent is supposed to do is to map the user intent to something that is already inside the knowledge base, because we don't build these mini applications from scratch. So and now the agent suggests to me the air quality earthlet, and ask which lake should we center and which month and year. And I can see here, so let's go to this. Yeah, but let me show you inside the architecture. So is there any? Oh. Right. So we saw, I think we saw this, like we get the answer, and I would like to now go to the agents part. So what is happening here under the hood? Essentially, we have two inputs. We have like an LLM expert, and this expert builds the system prompts for, in this case, two agents. These are the main agents. Like we have the user agent and the coding agent. So what is happening? We have like the user agent needs to have a certain world knowledge. What do I mean by this? The user agent needs to know what is his task, but also what is his environment. And we solve this by feeding the agent an Earthlet catalog. And what is this? This is a compressed version and metadata of all the Earthlets that you can see when you look into this list. Here, this is this list. So the agent knows all those Earthlets and knows data, like, for example, which data points are required from the user. So which data points the agent needs to know in order to fulfill the query. Also, in what scope, in what range the agent can suggest changes that are still derivatives or evolutions of the main template. And for the dialogue, for the sake of the dialogue and the mapping, also just by examples, what kind of questions the user could ask, just like few short examples that would fit this specific use case. And of course, a general description. So this is essentially one Earthlet out of the whole catalog. And this is the data the user agent sees. The user agent also sees a summary of the Earthlet that was built the last time, in case there was an Earthlet built already, because you can also change the Earthlet. Like you can always query the agent to make changes. And then, of course, this request is always going to the user agent. So the coding agent, this is the second agent, is only responsible for the coding, never talking to the user. And we separated this, because we saw when we were testing that otherwise it would just be confusing. So the separation makes it easier for each of the agents to operate within a very clearly defined space of a task space. And the user agent then maps the user intent to an existing Earthlet. This, in our case, does not mean that it has to be one-on-one the same, but the agent sees the possibility to derive a new Earthlet or a similar Earthlet from an existing one. And so he chooses the best match, or it. And then it writes an Earthlet mini specification, like it's a spec, a technical list. And we decided that we wanted the agent to write this spec at runtime. So you can see, this is, for example, what the user will see. This is the assistant markdown. This is what will be visible in the chat window. But all the rest, like this is, for example, okay, our system knows now the handoff to the coding agent is possible. And this is also just written by the user agent at runtime. And of course, we gave the user agent inside the prompt exactly the structure of this JSON that it needs to put out. And all of this is essentially the specification. And this is the only thing the coding agent will see regarding the conversation with the user. So it receives only this specification, of course, combined with a system prompt. A system prompt and a template. And this is like the clue from our system, or one of the clues, that we give the coding agent a single shot example. And as we like, when we put out the demo, we had like, I think 9 use cases that were have been pre-curated. So there was an expert, and Philip was the Earth observation expert that developed each of these use cases by human supervision. Like, it was not done via LLM. And essentially, what this code is doing, it steers the whole system into the direction that we wanted it to output code. Because, for example, we learned relatively fast that certain errors repeat because they're just in the training data. Or that it just overkills. When we just would ask the agent to write a mini app, an Earthlet from scratch, it would just do it all over the place. This is, I think we all know it from generative AI. So it needs kind of an anchor point. So there is expert knowledge inside the templates that our Earth observation expert prepared, and they will also be shown to the coding agent. So it has now the specification and the template and the order to basically create the Earthlet based on this, on the template, but also based on the specification. And it kind of synthesizes both of those informations. Yeah, that's basically how we have this idea of an evolution. Like, we show it one template, and from this template you can make changes, and this is essentially what we would call this dialogue. What is not working so well, or this is what was also not our intent, to make everything possible at the first shot. Like the most crazy use cases, it wouldn't work because we already ordered the user agent to basically skip and cut this at this point, that it says to the user, no, I cannot do this, but maybe you can work with this existing use case, and then of course referring to an existing template, and then we go from there, and then step by step we make this evolution. We also have the repair agent, but this is like just a minor thing here, because it basically is a copy of the coding agent, but it also receives the error codes in case there is a runtime error. And then it can like access the web, search, and basically try to fix the code based on the error that was encountered. And of course, we also need the Earthlet catalog to grow at runtime. And for this, we made a fourth agent, the Earthlet agent. Its task is basically to write the meta information for each Earthlet.
Okay.
Yeah, and then you get the code. And so, in case regarding the data handling, we accessed the Google Earth engine, which is a API, and all of this, like our catalog and the code, was saved simply in a Postgres database, like just text-based, and even the images are converted into what is it, base 64 and stored as a string. So we made it really like as a prototype. Yeah, but I think what is like the learnings that we actually had, I would say is
Hang on a second
yeah,
before we step
yeah.
in, before we get to the next step. Are there any questions so far? Okay, not yet. Okay, all right. And let's jump into the learnings.
Yeah, I mean, you can check out these learnings. It's a lot of text if you want like later, but I think for now, we essentially learned, like I learned during this prototyping, that first we can work with the base knowledge of the current foundation models. So our hypothesis was to assume that ChatGPT knows enough about Google Earth Engine because it's a publicly available API to actually be able to write code that has this kind of scope. Because it's not just a few lines, but it's also, of course, not a full fetch program. And this is also the second learning, I think the most important one, that we kind of figured out that our system as a prototype works within a certain range, like a certain window of opportunity, where we have enough degrees of freedom to basically enable the user to create whatever they want if it is related to Earth observation data and to the kind of mini apps that we were proposing, that our Earth observation specialist created. But it also has a limitation in the degrees of freedom that is given by the templates. So we don't say to the agent, just code whatever you want, but we really show it a single shot template. And from there, it can already derive the kind of app that we want. And yeah, and I think because I tested a lot, from my observation, actually, like, if you're not doing like super crazy analytics, like 90% of the queries were working in a first shot already. And yeah, so then, and if not, of course, there was this repair cycle. And I think what we also showed is that because we're kind of wipe coding a mini application at runtime, but also not in the scope that you would find at Lovable, for example, where it's really about vibe coding a whole program. So we kind of found a middle range that works well for this kind of querying data. And so you can, and I would be curious to hear what you could think of also how to transfer this to really other talk to your data use cases. Because yeah, we're writing full Python code and not just SQL queries, but it could be something like dashboard on demand, and so things that are a bit more sophisticated than just retrieving singular data points, and that can work with dialogue at runtime. And I think this is what we learned with this experiment. Yeah. So I think this is the overview.
Yeah, thank you, Benjamin.